Carotid sinus. The carotid sinus sits on both sides of the neck where the carotid artery branches. It contains baroreceptors that regulate blood pressure and heart rate. The technique involves striking or pressing with knuckles, thumbs, or the edge of your hand directly into the soft area on the side of the neck, just below the jaw angle. Baroreceptor stimulation causes a sudden blood pressure drop and can trigger a vasovagal response leading to dizziness, weakness, or unconsciousness. The disorientation is immediate. This works on bigger opponents because the neurological response is involuntary and universal. Size and strength cannot prevent the autonomic nervous system from reacting to this stimulation. The target is accessible during clinch exchanges and works when defending against front chokes or grabs. You can strike it or press it depending on your position. A direct hard strike to the carotid sinus can cause instant knockout through blood pressure crash. It doesn't require head trauma or concussive force. The response happens within seconds of stimulation, faster than most strikes or submissions. This gives you immediate advantage against a larger opponent. The tactical value is in the neurological shutdown. The bigger opponent cannot resist or power through an autonomic response. It levels the playing field instantly through biology, not force. Clavicle Smash. The clavicle or collarbone is a thin, S-shaped bone connecting the sternum to the shoulder. It's structurally weak and sits close to the surface with minimal muscle protection. The technique involves a downward strike with a hammer fist, elbow, or heel of palm directly onto the collarbone. You can also strike upward from below if you're in a grappling position. When the clavicle fractures, the pain is immediate and sharp. The arm on that side becomes largely useless. The shoulder loses structural support and breathing becomes painful. This works on bigger opponents because bone thickness doesn't scale with body size the way muscle does. Larger people often have the same structural vulnerability in the clavicle as smaller individuals. The target is accessible from standing or clinch positions and works when defending against grabs or chokes. You don't need knockout power, just clean contact on the bone. The beauty of this attack is mobility destruction. A broken clavicle eliminates punching power and grappling ability on that side. The bigger opponent's strength advantage is cut in half immediately. Unlike muscle pain that can be fought through with adrenaline, structural bone breaks cannot be overcome in the moment. This creates a severe handicap that allows you to escape or follow up with additional attacks. Eardrum Clap. The eardrum sits behind a thin membrane in the ear canal, designed to vibrate with the sound waves. It's extremely fragile and sensitive to sudden pressure changes. The technique is simple. Cup both hands and simultaneously strike both ears with open palms, creating a sudden compression of air that drives directly into the ear canals. The impact ruptures or severely damages the eardrum, causes immediate disorienting pain, and disrupts balance through inner ear trauma. Potential hearing loss is common. This works on bigger opponents because it doesn't require strength or power, just accuracy and timing. Ear vulnerability is universal regardless of size or muscle mass. You can execute this from clinch range when an opponent grabs you, or from inferior positions like being pinned against a wall. The disorientation from inner ear damage is immediate. Balance and spatial awareness collapse. The bigger opponent loses their coordination advantage and cannot pursue or fight effectively. Legally, this can cause permanent hearing damage, so it's only justified in legitimate self-defense where escape is necessary. The tactical advantage is clear. It creates an instant opportunity to disengage and run, which should always be the primary goal in street confrontations against larger attackers. Knee buckle. The knee is a hinge joint designed to bend in only one direction, held together by 4 major ligaments with no bone protection on the sides or front. The technique is an oblique kick, also called a linear side kick, driven directly into the front or side of the knee with the heel or bottom of your foot. When lateral force hits the knee, it collapses sideways, tearing the MCL or LCL. When forward hyperextension force is applied, it buckles the knee backward, destroying the ACL. The structural failure is immediate. This works on bigger opponents because joint integrity doesn't scale with body size. Heavier opponents actually put more pressure on their knees, making them more vulnerable to lateral attacks. The oblique kick can be executed from distance before the opponent closes the gap. It works as a defensive counter when a larger opponent advances, and it doesn't require close-range engagement, where their size advantage matters most. A destroyed knee eliminates the ability to stand, chase, or maintain balance. It completely removes size and strength advantages instantly. The oblique kick gained notoriety in MMA through John Jones's strategic use. Though controversial, it's devastatingly effective. The tactical advantage is clear. It keeps you at safe distance from a larger opponent, attacks a structural weak point that cannot be strengthened through training, and creates an immediate fight-ending injury that allows you to escape. Liver attack. The liver sits on the right side of the abdomen below the floating ribs. It's the largest internal organ, extremely vascular, with dense nerve supply connecting directly to the vagus nerve. The technique is a left hook, left body kick, or knee strike to the right side of the torso just below the rib cage, targeting the liver directly. When the liver is hit cleanly, Vagus nerve activation causes a parasympathetic nervous system dump. Blood pressure drops instantly. Breathing stops. The body folds forward involuntarily. A delayed collapse follows within seconds. This works on bigger opponents because internal organ vulnerability is universal. Abdominal muscles cannot adequately protect the liver from impact. Size doesn't prevent systemic shutdown when the vagus nerve is triggered. The liver is accessible from standing striking range and works in the clinch with knees. It doesn't require head-level strikes that bigger opponents can defend more easily with reach and height advantages. Unlike pain-based techniques, liver shots cause involuntary biological shutdown. The bigger opponent cannot power through or ignore the response. Their body simply stops functioning. Once a liver shot lands clean, collapse is coming within seconds. Adrenaline cannot override the parasympathetic system dump. Body-level attacks are less risky than headhunting against taller opponents, and one clean liver shot ends the confrontation regardless of size differential. Pure biology wins. Mandible torque. The mandible, or jawbone, connects to the skull at the temporomandibular joint and can be manipulated through direct grip on the jaw itself. The technique involves gripping the lower jaw with one or both hands. If possible, get your fingers inside the mouth and hook them behind the teeth for a stronger grip. Then violently twist or wrench the jaw sideways. This can dislocate or damage the TMJ, cause extreme pain, prevent them from closing their mouth or biting, and potentially fracture the jaw. It also gives you immediate head and neck control. This works on bigger opponents because the jaw is a lever that controls head position, and head position controls body position. Leverage negates size advantage. You can use this from bottom positions in grappling, during clinch exchanges, or when defending against mounted position or side control. Controlling the jaw forces the entire head and neck to follow. The bigger opponent must move where you direct or suffer structural damage. Fingers in the mouth, called fish hooking, is illegal in sport but completely legal in self-defense. It provides a grip that cannot be broken through strength alone. The tactical advantage is immediate pain compliance and positional control. It allows you to escape from inferior positions against larger grapplers and forces the opponent to prioritize protecting their jaw over attacking you. Vagus spike. The vagus nerve runs down both sides of the neck alongside the carotid artery. It controls heart rate, digestion, and parasympathetic nervous system responses. The technique is a sharp strike with fingertips, knuckles, or the edge of your hand driven into the side of the neck, targeting the soft tissue between the windpipe and the neck muscles. Vagus nerve stimulation causes an immediate parasympathetic dump. Blood pressure drops, nausea sets in, potential unconsciousness occurs, and breathing becomes disrupted. This works on bigger opponents because neurological override is involuntary. The autonomic nervous system responds regardless of size, muscle mass, or pain tolerance. The target is accessible from standing or clinch range. It works as a counter to punches or grabs and doesn't require wind-up or telegraphing. Finger strikes are faster than punches, penetrate defenses more easily, and can target nerves with precision that bigger opponents cannot defend against effectively. Unlike strikes that cause pain, vagus stimulation causes biological malfunction that cannot be ignored or fought through with toughness. The body enters a systemic shutdown. The tactical advantage is that small, precise strikes neutralize size advantage completely. They create an immediate physiological crisis that opens escape routes or sets up follow-up attacks. Speed and precision beat size and strength when targeting the nervous system directly. Wrist shear. The wrist joint connects the forearm to the hand through small carpal bones and ligaments. It's designed for rotation and flexion but extremely vulnerable to lateral pressure and twisting force. The technique requires you to grab their hand with both of your hands. One hand controls the palm, the other controls the back of the hand. Then you violently twist in opposite directions, creating shearing force across the wrist joint. This tears ligaments, potentially dislocates carpal bones, and causes immediate loss of grip strength and hand function. The pain radiates up the forearm instantly. This works on bigger opponents because small joint manipulation requires leverage, not strength. Bigger hands actually provide more surface area to grip and control, which works in your favor. You can use this when an opponent grabs your clothing, when defending against chokes, or when they post their hand during grappling. The leverage principle is simple. Two hands versus their one wrist creates a mechanical advantage that negates the size difference. With the proper angle, resistance becomes impossible. Once the wrist is damaged, the opponent cannot grab, punch effectively, or control you. Their size advantage becomes irrelevant without functional hands. Small joint attacks are quick and don't require extended engagement, creating immediate openings for escape.